pura agre corisita rakam kala pura T and T H T minus
calculating this pretty simply. And so let's just recall that we have this following chart of Laplace transformation. G evaluated at t plus tau. Okay, so let's see what we do here. So the first thing to do is to rewrite this piecewise function using the unit step function. And we can do that as follows. So this is equal to 2 plus u of t minus 3 times t squared minus 2. So that's the first thing to notice is that notice 2, this will be good for all t bigger than or equal to 0. But now we want it just to be equal to t squared if we're bigger than or equal to 3. So we include a t here, but then we include a negative 2 to counteract this. And then we have this plus u of t minus 5 times, and now here we're going to have to do t plus 1, and then it's going to be minus this. And then we're good. So let's see what we get for that. So we get minus t squared plus t plus 1. Okay, so now let's make sure this makes sense. So we're bigger than or equal to 3. So we include a t squared. Then we need to do is to rewrite this piecewise function using the unit step function. And we can do that as follows. So this is equal to 2 plus u of t minus 3 times t squared minus 2. So it's 5 times, and now here we're going to have to do t plus 1, and then it's going to be minus this. And then we're good. So let's see what we get for that. So we get minus t squared plus t plus 1. Okay, so now let's cancel each other out, and we're s 5s, and this is going to be c plus 9 minus 2 in the unit step function. And we can do that as follows. So this is equal to 2 plus u of t minus 3 times t squared minus. That's the first thing to notice is that notice 2, this will be good for all t bigger than or equal to 0. But now we want it just to be equal to t squared if we're bigger than or equal to 3. So we include a t squared here, but then we include a negative 2 to counteract this. And then we have this as plus u of t minus 5 times. Welcome, mathematician. I have another video for you in my series on the Laplace transform. If you don't know what the Laplace transform is, that's totally fine. Down in the description, I have an entire playlist introducing the Laplace transform. This is a really interesting and beautiful piece of mathematics that's so helpful to us with in differential equations. So I encourage you to check it out. Give this video a like so that the YouTube algorithm starts promoting more math videos. T minus a. Also evaluated at t minus a. The idea here is that I want to think of this as just being the function f, but it gets turned on, if you will. Let's see if we can find the Laplace transform of this function. You'll see it's a piecewise function, and if we want to take its Laplace transform, one way to do that is by using the step functions, or you might call them the unit step functions. So let's specifying my unit step function, I think of it like a light switch, flipping on and flipping off. So where does this first piece, this 0, turn on, flip on? Well, it flips on when t starts at 0, so I would insert a t minus 0. Where does this 0 stop? In other words, I subtract the unit step function for where it flips off. Well, this first piece flips off at t minus 1. So think of the first value, a light switch flipping on, the second value, a light switch flipping off. And again, you might use different notation. Sometimes you'll just see a u sub 0 or a u sub. Sub 1 here instead of the t minus, both would mean the same thing. How about this second piece? So I would have plus the second piece, t minus 1, and I do the same deal. Where does this second piece activate? Well, it activates at 1, so I put a u of t minus 1, and then I minus to signify the function flipping off at t minus 2. Last one, the third piece would be a t plus 1. It activates at 2, and it goes forever, so it never deactivates after it's turned on. So there we go. We've written this function in terms of its step functions, and you could simplify this a bit. 0 times anything is 0, so this will all just go away, and then I could just distribute the rest. Think about how the distributive law works. I would have t times u of t minus 1. I would have minus t u of t minus 2. I would have minus u of t minus 1. And then I would have minus a minus to make a plus u of t minus 2. And then I also have this piece. If I distribute, I have t times u of t minus 2 plus 1 times u of t minus 2. So you don't have to do this distributive stuff. Stuff as much as I did